Yes, okay. A very good morning to Honda. So I hope some of them are already known to me because in the last year I already taught the ECA 2 for some students, and some remaining students are also there for LE. So anyway, you are already known to me, and I think some of them are very familiar with me, so today onwards, your microprocessor and microcontroller group 1 classes are taken. Now we can see this. I think Ganesh sir will give some introduction about this. What are the different types of microprocessors? What is the history of the microprocessor? Then what is the architecture of the microprocessor? Then when the microprocessor introduced, what is the use of this microprocessor and other things. Okay, anyway, I once again give you some brief introduction to this microprocessor and all. Okay. Okay, you know that my name is Madhusudan. Okay, so this is I think this is the eighth or ninth time I'm taught this subject. So now see this today class we are going to discuss the some timetables and the syllabus, then course, what are the course outcomes and other things. Okay. Now see the timetable for you can follow the timetable today onwards. Now you can see this timetable. Now you can see this. Okay, you can see this. Just a second. Yes, you can see this timetable. It starts from today onwards. You know that now you can see this. You can see this. This is the new timetable. It starts at the 15:04 and all. Okay. So this is the group 1 timetable. Now we can see this. This is the group 1 timetable. People are still not waiting. Okay, no problem. Now we can see this on Monday. Our first hour MPMC, and Tuesday is the fourth hour, and Wednesday is the third hour, and Thursday is the second hour, and Friday there is no class at all, and Saturday we have some another class. Okay. Now see this in this entire semester we have only 5 different subjects, and one IPS subject is also there, and different labs are also there. So we have the lab called MPMC lab. MPMC lab is also there. So in this laboratory, we are going to perform some experiments like some additions, subtractions, and how to interface some devices to the microprocessor and microcontrollers and all other things in programming way and all. So use some different types of programming techniques to write the programs. Okay, so this is the timetable. You can follow this timetable. You can save this timetable. Okay, this is the online timetable. Okay, this is group 1. Then you can see the core structure, the mainly core structure of this core structure for this microprocessor. You can mainly see this core structure. Now see this. You can look at this. So this is our subject, third subject. This is our third subject. This is our third subject. See this microprocessor, microcontroller. You have 3 credits for this subject. You must pass the subjects. Then only you will get this 3 credits. Okay. Okay, you have seen this. You have totally in the third year, second semester, 9 different types of subjects are there, including labs and all. So this, so you can see the this is our laboratory also, microprocessor microcontroller laboratory. So this will have the 2 credits. Okay, total this semester will get the 21 credits to pass all the subjects. Okay, now we can see the syllabus, a brief syllabus. We have nearly 6 units are there in the syllabus, six units. Okay, unit 1 will introduces the what is microprocessor and what is the architecture of the microprocessor. Then what is the use of this microprocessor? Then how that microprocessor is working and all the things. You should remember one thing. Just as a machines and another subject, you just study that microprocessor and microprocessor microcontroller. You just learn from that one. So because it is already developed. Okay, it is already developed. This is very old microprocessor. It is introduced in the year 1978 and in the year 1978. It is already developed. You just see that one how that microprocessor is working. You just learn that one how the microprocessor is working, how that microprocessor architecture is drawn, how to frame that architecture. Then what are the how that microprocessor is working and like mission subject and okay. Then you come to the unit 2. It's important one. This will indicates the operation of the microprocessor. Operation mainly it will indicates the operation of the microprocessor. How this microprocessor will work. Microprocessors work in 2 different modes, minimum mode and as well as the maximum mode. So how this microprocessor convert, how this microprocessor is switch from minimum mode to the maximum. So now you can will thoroughly study at this unit 2. Then third one, what are the different interfacing devices to connect the microprocessor? What are different interfacing devices to connect this microprocessor? What is interfacing devices? What is the meaning of this interfacing device? You can see this I/O. I/O means here input and output. Input and output. I/O means here input and output. What are different types of input and output devices? It will be going to connect the 8086 microprocessor. I'll tell you one example here. For suppose you are connecting an USB, or some mouse, or some keyboard to the microprocessor, to the microprocessor. But microprocessor is not directly handled all these things, all the input output devices. Okay, microprocessor only is not handle all the things, nothing but an input. These are the input and output devices. Okay, as well as some printers, some scanners. Okay, some monitor. Okay, microprocessor is not able to alone control the all these devices, or not able to connect the all these devices alone to this microprocessor. So that's why you need some additional devices to interface this input output devices. Those are the these devices 8255 PP, programmable peripheral interfaces, PPI means it. Then you have the another one is nothing but the 8257 GMA controller, then 8259 controller, then 8279, 8259 nothing but the keyboard interface. Okay, 8279 keyboard interface, as well as the 8259 controller, programmable input controller 8259. So different controllers, again the different peripheral devices are necessary, are needed uh, to this microprocessor to connect this input output device. So without these help, nothing but 8255 PPI. Okay, again 8257, then 8259, then 8279. We are unable to connect this USBs or keyboards or monitors and all things. So because microprocessor is unable to handle all the things, so we need some interface devices. It's simply I will draw this one, a microprocessor here, a microprocessor here. So in interfacing devices, we require the interfacing devices. By interfacing device, you are going to connect this a keyboard or monitor or USB and remember. So an interfacing devices in between this input output devices. These are the some of the interfacing devices. 8255 is one of the interfacing device. Okay, as well as 8257 is one of the interfacing device. Okay, 8259 is one of the interfacing device. Then 8279 is one of the interfacing devices. So these interfacing devices again are used for the different purposes. Again, one interfacing devices is not sufficient to connect the all the input output devices. So that's why different interfacing devices are designed to meet the all the requirements. Okay, so this is a very important unit because if, it is somewhat lengthy unit also, but as well as at the same time important also. Then come to the fourth chapter, and microcontroller. And microcontroller, introduction to the 8051 microcontroller. So what is the difference between the microprocessor and microcontroller? We are going to discuss this one. So what is the advantages of a microcontroller when compared to the microprocessor? Again, you can see the architecture of this microcontrollers. So then how this microprocessor is working, nothing but the operation of the microcontrollers. So all the things we are going to discuss. Okay, then next one is the PIC, a programmable and interface controller, or a programmable interface controller, PIC 18 controller. You can see the PIC 18 is also one of the type of the microcontroller. Here in this entire this one is the some programming in C for PIC controller. So PIC controller you need to write the programming in C language. So how to write this programming to operate the PIC 18 controller. So different, what are different types of data types? You know that in C language we have different types of the data types. What are the logical operations? What are the some data conversion operations? So you know that different types of logical operations are there. So what are the different types of logical operations to compile the C programs are nothing but to write the C program. But PIC 18, you remember PIC 18, a program, PIC 18 controller, PIC 18 microcontroller. So you need to write the programs for this controller. At the same time, you are also need to write the 8086 microprocessor programming. You can also call it as a ALP, assembly language programming. You can call it as the at the same time 8051 microcontroller programming. Okay, 8086. Sorry, you can also see the PIC 18 controller. Okay, PIC 18 microcontroller. So we are discussing all these three things. For these three, you need to write the programs. You need to write the programs in your lab, MPMC lab. You need to practice this programs. Okay, So in MPMC lab, you need to practice the programs based on this three different types of devices: 8086 microprocessor, 805 microcontroller, as well as PIC controller, PIC 18 microcontroller. Okay, you see this? We have totally 6 units. So first 3 units is dedicated to the microprocessor. Remember, first 3 units is dedicated to the microprocessor. Then fourth unit is dedicated to the microcontroller. Okay, only microcontroller syllabus, and fifth and sixth chapters are specially designed for the PIC 18 microcontroller syllabus. Okay. Then see the we have different types of textbooks are there to read the microcontroller subject. So these are the some basic textbook they can given by the university. So you can follow these textbooks. First one is Kenneth J. Ayala is for only 805 microcontroller. It is very much helpful for this microcontroller. As well as another one is this is the very rare textbook. Okay, epic 18, so it is especially used for the PIC 18 controllers only. So PIC 18 assembly languages. Okay, so the textbook name is Muhammad Ali. Okay, Muhammad Ali textbook. So these are so many textbooks are available in the in our library also. Okay, so at the same time, so the third textbooks is also there, but in the textbook is missing here. The textbook, third textbook is this one. This fifth one you can place here. Okay, okay, that is the advanced microprocessor. So a Tata McGraw-Hill edition, Tata McGraw-Hill edition, the AK Ray. So they are not mentioned here, but so this is the prescribed textbook for 8086 microprocessor. Remember, this is the textbook for 8086 microprocessor, AK Ray. Remember, this is the AK Ray. Okay, so whenever you want to read and all other things, whenever you are interested to read the some another topic, we can follow the next choice. You can give it to the this one, a very standard textbook, Douglas VH. You can call it as the Douglas VH. Somewhat difficulty to study this textbook. Okay, you can difficulty to understand this textbook, but these three are necessary. So the entire microprocessor microcontroller syllabus is available in these 3 subjects. In these 3 textbooks. Okay, first one is Kenneth J. Ayala, used for 805 microcontrollers. Then next textbook is PIC controller textbook. The author is Muhammad Ali Majidi. Then the third one is this is the textbook. Third one is this is textbook. So this is the textbook, advanced microprocessors and interfacing. So for that we are using for the 8086 microprocessor. These 3 textbooks are necessary. Okay, to read the entire syllabus of the microprocessor and microcontrollers. Okay, so another textbook is also there to useful for microprocessors at the same time microcontroller. Is one textbook is also available. It is very easy to read. Okay, and very easy to understand as a student way. So that okay, the textbook name is that is the Saumitri Kumar Mandal. Saumitri Kumar Mandal. The textbook name is Saumitri Kumar Mandal. So this one textbook is sufficient to read the 8086 microprocessor and 8051 microcontroller. So this 2 is available. But PIC 18 you must require this Muhammad Ali textbook. Okay. So Saumitri Kumar Mandal is also on textbook is available to read the 8086 microprocessor and 8051 microcontrollers. But these three, Kenneth J. Ayala, then Muhammad Ali, then A.K. Ray are the standard textbooks. Okay. 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 This one, Samudra Kumar Mandal, is easy to read at the same time. As a student point of view, it is somewhat easy to understand. Okay. This is regarding the textbooks. Okay. So so whenever you want to buy the textbook, please prefer this any so we want to I mean buy something is Samudra Kumar Mandal is in it for you because it covers the 8086 as well as the 8051 microcontroller board, as well as you can take this some xerox of this because this textbook is very costly. You just take the some xerox because you are using only two chapters for this entire test. Okay, that's why you can take the xeroxes. So whenever you want to buy, so you can prefer this something one Mandal 8086 and so it will covers the 80% of the syllabus 8086 and 8085. Okay, so but in our library is also a lot of textbooks are available. Something Mandal textbooks are available. Then AK Ray textbooks are available. Then Kenneth textbook available. Then Pick 18 controllers are very less textbook, very less quantity is available, but the remaining are available in huge quantity. Okay, the next one, why you are first of all why you are study this microprocessor. What is the use of this one? What is the purpose of this one? After you want to study the entire syllabus and, what you are going to learn from this, that you can call it as the course outcomes. After the completion of the syllabus, a student must be ability to know these four things. After the completion of the syllabus, a student must be ability to know this four. We can call it as a course outcomes. Is nothing but is like some aim. So why you are studying microcontrollers? What is the use of this one? So you can represent in the course outcomes. Outcomes means when once the student is completed this syllabus and all, what is going to learn from him? What is going to learn from what is he was already learned from that one. Okay, so this is you can call it as CO1 means a course outcome. So after the completion of the syllabus, the student is able to draw the architecture of 8086 microprocessor and 8051 8051 and the big 8 microcontroller architectures. Architectures means the diagrams of the microprocessor, simply the diagrams of the microprocessor like machines and all, the diagrams how that microprocessor architecture is available in a 8051 microcontroller and pick 8 microcontroller. The student is ability to draw. So after completion of the first and the syllabus, the student is ability to draw the architectures of these three, the basic structure of these three devices. Then CO2 nothing but course outcome 2. So after completion of the syllabus, the student is ability to applying the instruction set. You know that instruction set. What is the instruction set means here? A set of instructions to write the program. To write the program. So like in C language, we have some instructions are there. It's like printf. You have some instruction format are there. Scanf, you have some different specific format are there. Some instruction format are there. Likewise, microprocessor is also some specific instruction format is there. Some move instruction, then okay. So like this instruction, add instruction, okay, okay, subtract instruction, then multiply instructions, then division instructions. Different types of instructions are there to write the programs. Okay, so after the completion of the syllabus, the student is able to know the different types of instruction set to write the programs of 8086 microprocessor and 8051 uh, controller at the same time pick 18 programs also. Pick 18. Okay, then what is the third one? Course outcome 3. Course outcome 3. So after the completion of the syllabus, the student is able to interface different types of devices. You know that what are different types of interfacing devices? I already said 8255, 8259, 8279, 8257. Different types of interfacing devices are there. So student is able to know the how to interface different types of interfacing devices to connect the 8086 megahertz as well as 8055. Then the last one, important one, course outcome 4. After the completion of the syllabus, the student is able to design and develop 8086 microprocessor and microcontroller based systems for real-time applications using low-level languages like ALP. This is nothing but the ALP means here assembly language programming. Okay, ALP means assembly language programming. After completion of the entire syllabus, student is ability to write new programs to develop new programs to interface different types of devices or to operate different types of devices or to control the different types of devices. The student is able to write his or her own programs after the completion of the syllabus. Okay, nothing but like as an automation and all automate. Okay, but these are used for the low level languages and assembly language program. I think so many of you are very much familiar about the Arduino and Arduino. So Arduino, they are using the 8051 microcontroller. Arduino, they can use the Arduino also. The Arduino also they can use this 8051 microcontroller in the Arduino. So you know that most of the people will know that 8051 microcontroller. I mean programming in Arduino they can use some different types of languages. One type of Arduino language. Here we are using the assembly language program. Okay. Okay. These are the some basic course outcomes of this microcontrollers. So we'll guarantee that after the completion of this entire syllabus, you must meet this 4 course outcomes. Okay, so on that way we can start the entire syllabus. Okay, on that way we can take the classes every day. You can meet this 4 aims is nothing but 4 aims. You can meet these 4 aims or 4 outcomes. Okay, so we'll definitely guarantee that. So we'll meet this all these 4 outcomes after the completion of the syllabus, after the completion of the course or whatever. Okay, okay. What is the first one? A student must be able to draw the architectures. Then what is the second one? So the students must be know the what are the different instruction sets. Then what is the third one? His ability to interface the different types of input-output devices by using these interfacing units. And what is the fourth one? He's capable of writing their own programs to develop some different applications to control some different types of devices. So we are guaranteed that. Okay. So these are the 4 devices. So we can see this a small images of this microcontrollers and microprocessors and microcontrollers. Now you see this. This is the microprocessors look like. Remember, this is a microprocessor look like. This is a microprocessor. This is a microcontrollers look like. This is a PIC18 microcontrollers look like. We can observe this different types of. I mean, you can observe this. these three different type of the devices. All the devices, whatever you are going to study, is developed by the Intel Corporation. Intel Corporation. All the three devices is developed by this Intel Corporation. 8086 microprocessor, 805 microcontroller, and 80 microcontroller. All these three devices at the same time interfacing devices 8255, 8279, 8259. These devices is also developed by the Intel Corporation. Whatever you are going to study, all the devices is developed by the Intel. Okay, so you can see this here. They can mention the introduction year 8086 microprocessor. So in the year 1978. Okay, so different devices are developed in different times. So our intention here is to you have to know the what is a microprocessor and then what is the microcontroller. What is the basic difference between the microprocessor? You see this microprocessor and microcontroller is looking like same devices. On the outer side, you can see this epic also. You can see this in the outer side. These three devices are looking quite similar. But what is the difference between these three devices? Or you can categorize into the two different ways. First one is the microprocessor and the microcontrollers. Whatever it may be, it may be of 18 controller or 805 microcontroller, whatever it may be. So it can perform the same things. So you can categorize into the two ways, microprocessor and microcontroller. What is the difference between this microprocessor as well as microcontroller? So which one is more advantages when compared to this two? Okay, you can see this. Okay, a small. Okay, you can see this. You can look at this one. The small differences between the very small difference between the microprocessor as well as the microcontrollers. So this may be of different types of microprocessors available. We have 8085 microprocessor or 8086 or whatever it may be, or 4004 microprocessor, whatever it may be. Different types of microprocessors is available. Okay, whatever it may be. Okay, at the same time we have different types of microcontroller, 8051 microcontroller, PIC 18 controller, whatever it may be. So as I said, we can characterize into the two ways, microprocessor as well as the microcontrollers. What is the advantages of this controller? So microprocessor, you see this microprocessors are used for the big applications. Remember. So but microcontrollers are only used for to execute the a single task within an application. You remember in our computer, you are using laptops and all, and all. So whenever you are buying the laptop and all, you can see the microprocessor configuration, not the microcontroller configuration, not the microcontroller. You can see the microprocessor configuration. So it is 3.2 gigahertz or 2.8 gigahertz or 2 gigahertz. You can see that microprocessor configuration. But you see this the difference between the one major thing is the cost. The microprocessor cost is very high when compared to the this cost. Nowadays, the Arduino, you know that what is the Arduino cost? Nearly 300 rupees. An Arduino is available, but Arduino it has the some interfacing devices also. Will directly connect the some monitors like LCD or LED or LCD or keyboard and Arduino. So it has some interfacing devices also available now. But this a single device, 805 microcontroller. Nowadays the cost is 100 rupees. and below also is available 100 rupees. But you know that the cost of this microprocessor on the days at an nowadays an i3 or i3 processor, i4 or i5, whatever it may be, and a minimum of 5,000 and above is a minimum of 5,000 and above. But nowadays you can see the cost of the micro uh, controller below 100 rupees is also. Okay, because it is not easy to replace. It is easy to replace because of the cost. Because of the cost issue, so we are not easy to replace. It is easy to replace. So the power consumption is also somewhat high. So when compared to this one, 8051 microcontroller, the power consumption is less because those are developed in the CMOS technology. But nowadays, these microprocessors is also developed on CMOS technology. CMOS means is nothing but the and a transistor technology. Remember, transistor technology. The devices in microprocessors and microcontrollers, we are using the some then IGBTs, some is like diodes and so these devices, transistors and some diodes and all, they can develop the using the CMOS technology. So in the earlier days, they can use the solid state technology. Nowadays, they can use the CMOS technology. Most of them are they are using the cameras also nowadays. So on the cameras also, they can represent the CMOS technology. Okay, I think some people are already identified that CMOS. Then the major difference between, you see this is our difference. This is our difference. This is the important point here. What is the major difference between microprocessor and microcontroller? So it doesn't, a microprocessor, it doesn't has the RAM, okay, row and input output ports. Input output ports means here, so these ports nothing but USB port and keyboard ports and HDMI port and all, you can remember, and it doesn't have that one. So separately you can connect the ports and as well as RAM and ROM and external hard disk. You can think that in our laptop and our desktop also, and I mean internal memory and all, it is not available. Okay, but a microcontroller has the RAM, ROM, and I/O ports is also available. Like a Arduino, like a Arduino. You know that Arduino. It has an Arduino has a RAM, an Arduino is a ROM, as well as input output. Is nothing but you are directly connected the I/O ports to this device. Okay, that's why microprocessor can simply call it as a CPU on a chip. Remember, microprocessor can call it as a CPU on a chip, but a microcontroller you can call it as a computer on a chip. Remember this word computer. This word computer, it can perform all operations in one IC. In one IC, remember, a chip means here an IC. An IC, integrated circuit. IC means here an integrated circuit, a chip. So at one chip, so it like it performs the computer. So see this, you know that what is CPU? What is CPU? What is CPU? CPU has the arithmetic and logical unit. You have the, then what is the then what are the another one? So ALU, you can call it as ALU, and timing and control unit. Okay, some days different types of some days is available. So additionally, you can add the, this is a microprocessor basic diagram. Additionally, you can add the ROM or RAM or input output devices. Additionally, but this microcontroller in the chip only. This is the one chip. This is the chip one. This is the another chip. So we can add this one, interfacing this one. But now microcontroller is a CPU. Okay. At the same time RAM. At the same time ROM also. All the devices are. Okay, this is a major difference between nothing but a microprocessor is a nothing but a CPU, nothing but it has only a arithmetic and logical units, some timing and control units, some registers. But whenever it will work as a whenever it will work, it definitely need the RAM and ROM, RAM and ROM. But here see this a microcontroller and chip, an entire chip. It has this all the things, all the different things. Nothing but the RAM and ROM and IO is also inbuilt in the. Okay, this is a major difference. That's why a microprocessor you can call it as a CPU on a chip. Then microcontroller you can call it as a computer. Nothing but it can perform all the operations. But you have some doubt about that. And what about the microprocessor? It will perform all the operations or not? Yes, microprocessor is also perform all the operations, but additionally you are adding the RAM and ROM and input output ports to this CPU. But microcontroller inbuilt it has the RAM and ROM and the IO ports. That is the major difference between. That's why microprocessor cost is very high when compared to the microcontrollers. Okay, so so in the next class, we are going to discuss the microprocessor introduction. What is the evolution of the microprocessor? Okay, then what is the something to know about that 8086 microprocessor? Then what is the meaning of 86 and what is the meaning of 85 and 404 and all other things we are going to see in the next class. Thank you. Thank you for joining the class. Thank you all.